This is 8.6 special right triangles. What patterns or relationships exist between the side lengths of 45, 45, 90 and 30, 60, 90 right triangles? That refers to the degree measures. So when we have what we call a 45, 45, 90 right triangle, we're talking about the angle measures. So you can see two 45-degree angles and a 90-degree angle. When that happens, there are special relationships that happen in terms of the side lengths. Well, first off, what we should know is that this is an isosceles triangle. If the two angles are the same, so 45 degrees, which they are, then that means that the sides that are opposite those angles, that side and that side, will also be the same. Okay, so we call these the legs of the 45, 45, 90, and they will always be the same length. So let's say this is x, that means this is also x. And then, let's go ahead and give it a measurement. So say, I don't know, let's just say 2, for example. If that's 2, then this side is 2. And now watch what happens. I can use the Pythagorean theorem to solve for the missing third side. So 2 squared plus 2 squared equals c squared. 2 squared is 4, so that's 4 plus 4 equals c squared, so that's 8 equals c squared. And then if I take the square root of both sides, that tells me that that missing side length, which is c, is equal to, now the square root of 8 is the same as the square root of 4 times the square root of 2, and the square root of 4 is just 2. So this is 2 times the square root of 2. 2 times the square root of 2 is the length of the hypotenuse. Now you'll notice the legs were 2, and now the hypotenuse is 2 times the square root of 2. So that will always be the case as well. The hypotenuse is always going to be whatever the leg is times the square root of 2. So that's some rules that you need to write down. Make sure that you get these all down. In a 45, 45, 90 right triangle, the legs of the right triangle will always be congruent. Always be the same. So once again, if this leg is x, then the other leg must be the same length, x. The hypotenuse will always be the length of the leg multiplied by the square root of 2, like we just talked about in this note. So if the leg is x, then the hypotenuse is x times the square root of 2, or we say x rad 2. And yes, you could multiply by the square root of 2 to get a decimal, but we just keep it in, oftentimes in special right triangles, we just keep it in radical form. It's quicker, it's easier, and it's accepted. So this is what you really need to write down and what you really need to know. For a 45, 45, 90, the legs are congruent, and then this one especially, the hypotenuse is always equal to the leg times the square root of 2. There's one other type of special right triangle that you need to know about, and we call it the 30, 60, 90 right triangle. A little bit different rules than the 45, 45, 90. So let's say that this leg right here was 10 in length. I can use trigonometry to find the two other missing legs. For example, this leg right here, let's call this AB, this leg, AB. Say I wanted to find AB. I guess we could just call it X for right now. We can use trigonometry to solve for this missing leg. So we could use the tangent function. We could say the tangent of 30 degrees equals 10 divided by x, right? Opposite over adjacent. You could say tangent 60 degrees, but then you would just say equals x divided by 10 then, right? So you could do that, right? And you would get an answer, and that would be perfectly fine. But with special right triangles, we want you to know shortcuts, and we want you to know the relationship so you can quickly get the answer. So with that said, here are some 30, 60, 90 rules that you need to know, the relationships of the side legs. So there's a couple of them here, so make sure that you write these down and that you know them. First of all, the hypotenuse is always opposite the 90-degree angle, so we know that. That's the hypotenuse, right? I can label that right here, hypotenuse. Next is, unlike the 45, 45, 90, the legs are different sizes because we have different angle measures, right? This is a 30 degree, this is a 60 degree. It's not 45 and 45 like the other one, right? So the legs are not the same length. We have a shorter leg and we have a longer leg. The shorter leg is always opposite the smallest angle. So 30 degrees is smaller than 60, right? The two acute angles. So the short leg is always opposite the smallest angle. So 30 degrees is there. Opposite that, we call that the short leg. I will sometimes abbreviate it SL, short leg. And then obviously opposite the 60 degree angle, which is the larger of the two acute angles, is the long leg. So we have two legs. One is shorter than the other, and one is longer than the other. Oftentimes I'll abbreviate that LL, long leg. So that's how you can always tell which one's the shorter leg and the longer leg. Shorter leg, opposite the smaller angle. Long leg, opposite the larger of the two angles. Remember, the hypotenuse is always across from the 90 degree angle, so we should never confuse that. So really, you just need to understand the difference between short leg and long leg. Here are your 30, 60, 90 rules that you need to memorize. Okay, first of all, recognize you have a special triangle. Let's label it. So remember that this is the hypotenuse over here. This is the short leg over here and the long leg here. Short leg always across from 30 degrees. Long leg always across from 60 degrees. So remember that. The hypotenuse will always be twice the amount of the short leg. The short leg, let's just give it an amount. So let's just say the short leg is x. We're just going to give it a variable x. Well, then the hypotenuse is just going to be twice that amount. So if the short leg was 5, the hypotenuse would be 10. If the short leg were 8, it would be 16, and so on. So we say the hypotenuse is 2x. So that just means 2 times the amount of the short leg. If the short leg is x, the hypotenuse is 2 times x. The long leg is the short leg times the square root of 3. Don't get that mixed up with the square root of 2. It's not the square root of 2. That's the 45, 45, 90 rule. So don't get mixed up with that. The long leg is always equal to the short leg, whatever the short leg is, times the square root of 3. So in this case, our short leg is x. So our long leg would be x times the square root of 3. So we just say x rad 3. And that's it. Those are the rules that you need to remember for your two special right triangles. So now it's just about practicing and remembering. So let's try that here. So we're going to do a bunch of examples here, and I'm going to do them pretty quick. So pause as much as you need, rewind as much as you need, and get these examples in your notes. Number one, we can see that this is a special right triangle. I have, first of all, 90 degrees, and then if this is 60 degrees, that means my other angle is 30 degrees, right? So I can see that the long leg is given to me, right? It's across from the 60 degree angle. So we need to find the measurement of the other two sides. So I'm going to look at this, and I'm going to remember that, oh, you remember back from your rules, it was the short leg times the square root of 3, right, to find the long leg. Well, if I know the long leg, though, I need to go backwards, and I need to divide by the square root of 3 in order to find that. So I can do that by just saying 5 square root of 15 divided by 2, and then divided by the square root of 3. Well, remember, I can flip and multiply. So that's a rule that you learned in math before, that we can change division to multiplication. I could say 5 square root of 15 divided by 2 is the same as multiplying by 1 over the square root of 3. So now when we multiply, I can just multiply straight across. Anything times 1 is itself. And then 2 times the square root of 3. So I can go ahead and divide these square roots. So 15 divided by 3 would give me 5. So that's going to give me 5 times the square root of 5 over 2. That was a really tough type of example, but I just want you to understand that the rule is short leg times the square root of 3 gives you the long leg. So if I'm going backwards to find the short leg, I need to divide by the square root of 3. And that's essentially what we did. Now, I did some other skills here that you might find difficult or tough, but that's ultimately how I got the answer. So this is my short leg, 5 times the square root of 5 over 2. And then remember, the hypotenuse here is just 2 times the short leg. So whatever the short leg is, this times 2 is the hypotenuse. So if I just take 5 times square root of 5 over 2, and I just multiply it by 2, which is 2 over 1, I just get 10 square root of 5 over 2, and then 10 divided by 2 is 5. So it's 5 times square root of 5. And I could have just canceled these as well, and that would have been fine. Again, tougher type of examples, just understand what the rules are, and you're going to have a little bit easier examples to work with. I'm going to skip around a little bit. We're not going to do all the examples. We don't have time. So in this one, we have a special right triangle. This is a 45, 45, 90 right triangle. So remember the rule is that what? The legs are the same. So V and U are the same length. So we just got to figure out what it is. So the rule is what? Take the leg and multiply it by the square root of 2 to get the hypotenuse. But if you already know the hypotenuse, you need to divide by the square root of 2 to get the leg. It just depends on which one you know. So if I take 8 and just simply divide it by the square root of 2, that is the leg. Both of them, and they are congruent. So really, it's just as simple as that. Now, if you have like a decimal answer, you can just punch that in your calculator. 8 divided by the square root of 2 gives me that. Whoops, I pressed the wrong button there. 8 divided by square root of 2 is that. There we go. So it would be like 5.65, but you don't have to change it to a decimal. Oftentimes, we just leave it just like that in radical form. Hopefully you recognize this as a 30, 60, 90 right triangle, right? The hypotenuse is given to us, see, across from the 90-degree angle. So if we remember, the short leg times 2 is the hypotenuse for the 30, 60, 90, right? So if this is 4, the hypotenuse 4, that means that my short leg across from the 30 is 2. So this is simply going to be 2. And then the rule is for the long leg, it's just the short leg times the square root of 3. So 2 times the square root of 3. So I'm just going to write 2 times the square root of 3. And that is, you've solved for the missing sides. So if you know the pattern, you just write the answer. There's no really work to be shown. So you should recognize this one as a special right triangle of 45, 45, 90, which means that the legs are the same, right? The legs are congruent to each other. So this leg is 4 times the square root of 2. So that means that this leg is also 4 times the square root of 2. And then the rule is simply take the leg and multiply it by the square root of 2, and you get the hypotenuse. So I'm just going to take the leg, 4 times the square root of 2, and I'm going to multiply it by the square root of 2, because that's the rule. And when I do that, I get 4 times the square root of 4, right? And square root of 4 is just 2, so really this is just 4 times 2, which is 8. And that's your hypotenuse. This one is a 30, 60, 90 special right triangle, and we are given the short leg across from the 30-degree angle, right? So that's when it's the easiest, because then all I have to do is multiply it by 2 to get the hypotenuse, because that's the rule. So I'm going to say 2 rad 2 times 2 is 4 times square root of 2. So hypotenuse is 4 times the square root of 2. And then I need to take the short leg, 2 rad 2, and I need to multiply it by the square root of 3 to get the long leg, because that's the rule. So 2 times square root of 2 times square root of 3 is 2 rad 6. And that's the long leg. This is a 45, 45, 90 right triangle. We know the hypotenuse, so the hypotenuse is the leg times the square root of 2 to get this, right? So we need to divide by the square root of 2 to get the leg. So I'm just going to take 9 over 2, and I'm going to divide it by the square root of 2. But remember, that's the same thing as what? Multiplying by 1 over the square root of 2, same thing. And we get 9 over 2 times the square root of 2. And in a 45, 45, 90, that means both of the legs are that length. That's a little bit more difficult. As long as you're understanding the rule is what matters.